Hey, Calc kids! I hope you guys have had a great spring break, and as we get back started, we're going to start Chapter 7. We skipped Chapter 6 completely. As we are working in Chapter 7, we're going to really focus on regions of areas between two curves. We're going to find the area between two curves if we use integration, and then we'll do the accumulation process in video 2. So we're going to do the first two sections today. So we've found the area under a curve and between this baseline here. Now we're going to find the area above a curve and under another curve in between two curves. Same process actually. We find the area of the first curve. We subtract the area underneath the second curve. So what we end up getting is that middle section. We can use the limit process, but we end up getting the integral from a to b of f of x minus g of x. And f of x is always the top function, and g of x is always the bottom function. So it kind of creates that little nook for that particular area section. All right, so there we are, the area between two curves. The a is the left bound and b is the right bound. So going from the left side to the right side of the graph. Okay, we got this. So our first problem here, we're going to take the area underneath x squared plus 2. We are going to subtract away the area of negative x, and from here we're going to get this kind of weird looking trapezoidal shape. So our bounds that we're given in this particular case go from x equals 0 and stop at x equals 1. So as we're setting up this integral, stuff's falling off the desk, sorry. We are going from a to b. That's starting on the left of 0 and the right is 1. You take your top function, subtract away your bottom function. In this case, that's minus a negative x. I would simplify that first. I am a huge fan of simplifying and then integrating. So first we're going to simplify it to x squared plus x plus 2 with a double negative. Integrate that, put in your bounds from 1 to 0, and we get an area of 17/6 for this shape right here. Alrighty. So not too hard. This is a pretty basic section for us to get our feet wet in area curves. So now what if the curves intersect? So most of the time we're not given go from 0 to 1. Instead they're going to say, well, what's the area in between these two curves that intersect? So this time, before I can even start the process, I need to find where do they intersect. The easiest way to do this is to plug both curves into your calculator and do your calc intersect. If you don't have a calculator, if it's the non-calculator portion of the text, then you would set the two equations equal to each other. We can factor to solve in this case. Either way, we have two bounds of x is negative 2 and 1. We're going to have the negative 2 be the lower bound and 1 being the upper bound. So again, you can always set them equal to each other. If the calculator is available, plug them on in, calc intersect, it'll save you some time. So the top curve was the parabolic function, subtracting away a positive x curve. So this time we get an area of 9/2. So that 9/2 represents this area, 4.5. Okay. All right, again, we can handle these. These are just basic integral functions. There's nothing scary. This is the first scary problem we've got. Okay, so in this case, as we look at this function, I'm going to put me on full screen here. There are two ways to look at this. We can either do two separate integral areas. If we do two separate integral areas, we have to do our first area as this pink section, integrate from 0 to 1 of the square root of x minus the negative square root of x. In other words, adding the square root of x on top of it. Then we would add on to that section the yellow piece which the top curve is still the square root of x, and then we're going to minus away x minus 2, the linear function. So we would have to do two separate integrals with two separate bounds to get this area. Or we can do one integral and do a dy problem instead of a dx problem. So that's what I'm going to show you. So we're going to look at this as a dy problem instead of a dx problem. Okay, if we're thinking about this, we have to do the top minus the bottom. In our problem previous, we had the top function pink, the bottom function orange. So with that, we have to think of this as rotated. So the function that's furthest away from the y-axis is the top function, and the function closest to the y-axis is the bottom function. So what we're going to do here is the linear function minus the quadratic function. So we're going to have the integral here of our y plus 2 minus the squared of y. Okay? Our bounds then go from here, we would go from left to right. So as I rotate that, it's actually going to go from the bottom to the top. So if we look at our intersection points here, we have 2, -2, and 4, +2. So my bounds are going to start at y value, -2, and end at a top y value of +2. Getting this all set up, this is what we're looking at. So we have our blue function on top, we're subtracting away our y, our red function. The bounds are y bounds because everything is in a y function in this case. We're integrating with respect to y's, not x's. So we're going to simplify it. The first thing I did is I put it in high power order. I integrated it, and as I did that, see that little bit on the bottom there, is a pretty basic integral, and I simplified down to an 8/3 value. We've got 8/3 plus 2 plus 4 minus a total of 8/3 plus 2 minus 4. Distributing that negative, we get -16/3. These cancel, and 4 plus 4 is 8. So we get 24/3, which is -16/3 plus 24/3, which is 8/3 for a total area of that shape. This is a much better option than trying to do two separate x integrals. All right, I will be in touch soon, but this is our first lesson. This should get you through the first homework section of 7.1 and most of, for sure, 1 through 27 odd, and I think 37 and 49. Double check through that. Check all your work on thecalcchat.com, and then just submit a picture for me that I can prove that you did the work. We're going to think about quizzes and tests as we go. I will come up with something. Good luck. Please text me questions, email me questions, whatever you have as we're going here. Good luck and have a great break.